suppose the gravitational force varies inversely as the nth power of distance, then the time period of a planet in circular orbit of radius capital R around the sun will be proportional to. Actually, the gravitational force, it varies as R square of the distance, that is Newton's law of gravitation. But in a new condition, according to condition of the question, it is said that the gravitational force varies inversely as R raised to n, the nth power of the distance. So it is not proportional to, inversely proportional to R square. Instead of this, F is inversely proportional to R raised to n. In this case, what will be the time period of the motion of a planet around the sun? And the distance of that planet from the sun is capital R, means small r is capital R. Now, if you remember the derivation, how we found out the periodic time of a satellite, the same method you can use here. Centripetal force is provided by the gravitational force. When a satellite is revolving around the planet, or when a planet is revolving around the sun, the motion is circular motion. Circular motion के लिए क्या लगता है? Centripetal force. And from where is that centripetal force provided? By the gravitational force. So centripetal force is equal to gravitational force. Centripetal force is mv square upon r. But since we have to find the time period, हमको time period find करना है, so we will not take this formula. We can take mr omega square. अगर ओमेगा यूज करेंगे तो उसमें t आएगा कैपिटल T. So in place of mv square upon r, we can use mr omega square. So centripetal force is mr omega square, which is equal to gravitational force. Gravitational force. Now, gravitational force is proportional to m1, m2 upon r raised to n. R square की जगह यहाँ पे क्या है? R raised to n. Now, this is a constant. Means F is proportional to 1 upon r raised to n. F is proportional to 1 upon r raised to n. And this r in this case is capital R. So this r is also capital R. So F is equal to k upon r raised to n, you can say. बाकी सब तो constant है ना? If you remember the Newton's law of gravitation, F is equal to g m1 m2 upon r square. G is a constant, capital G. M1 m2 is a constant. So F is equal to k upon r raised to n. This value of k, this value of F, you can put here. So m r into omega square 4 pi square upon t square is equal to gravitational force k upon r raised to n. We have to find the periodic time. तो इसको उधर ले जाओ. So t square will be equal to m r into 4 pi square into ये ऊपर आया r raised to n upon k. Now if you observe this, m is a constant, 4 pi square is a constant, k is a constant, means t square is proportional to r into r raised to n, that is r raised to n plus 1, r raised to 1 plus n, that is r raised to n plus 1, or you can say t is proportional to, ये square है तो यहाँ पे क्या होगा? Square root. T is proportional to r raised to n plus 1 by 2. So the periodic time t is proportional to r raised to n plus 1 by 2. So your answer is A. T is proportional to r raised to n plus 1 by 2. That is A.